Active diffusion, also known as active transport, is a process that moves molecules across a cell membrane against their concentration gradient, requiring energy input from the cell. This contrasts with passive diffusion, which moves molecules down their concentration gradient without energy expenditure. Let's examine active diffusion in detail. 1. The mechanism of active transport. Active transport utilizes transmembrane proteins, often called pumps or carriers. These proteins bind to the specific molecule being transported and, using energy, typically ATP, undergo a conformational change that moves the molecule across the membrane. This process allows molecules to move from a region of lower concentration to one of higher concentration, a feat impossible through simple diffusion. 2. Types of active transport. There are two main categories. Primary active transport. This directly uses the energy from ATP hydrolysis to drive the movement of molecules. A prime example is the sodium-potassium pump, Na plus K plus ATPase, crucial for maintaining the electrochemical gradients across cell membranes in animal cells. This pump expels sodium ions Na plus from the cell and imports potassium ions K plus against their respective concentration gradients, using the energy released from ATP breakdown for each cycle. Other examples include proton pumps H plus ATPases in stomach cells for acid secretion and calcium pumps Ca2 plus ATPases for maintaining low cytosolic calcium levels. Secondary active transport. This type of transport uses the energy stored in an electrochemical gradient established by primary active transport to move other molecules. It doesn't directly use ATP, but relies on the potential energy created by the pre-existing gradient. Two common mechanisms